Of circuits and networks. We have seen about two-port networks in our previous classes. What we have seen in two-port network? About Z parameters, Y parameters, ABCD parameters, and H parameters. In today's class 6, we are going to see the reciprocity and symmetry conditions of these parameters. So broadly we are taking 4 parameters here and we are going to find out the reciprocity condition as well as the symmetry condition. So how do we do that? So we'll start with open circuit parameters, that is called as impedance parameters. Here you can see a two-port network where you have input port side voltage as V1, the current which is flowing is I1. Similarly, output port voltage V2 and current is assumed to flow I2. And the standard Z parameters are given by equation 1 and 2. So if we short circuit the port 22 dash, that is the output port, which means that V2 will be equivalent to 0. So let us substitute this value V2 equal to 0 in equation 1 and 2, and we have shorted here. We are assuming the input voltage to be as source voltage, that is Vs, making the current I1 to flow into the 2 port, and I2 it is going to depend on I1. In fact, when output voltage is set to 0, we can assume a current I2 dash which is flowing in this circuit, closed circuit, like this, and I2 dash it is quite opposite to I2. So with these assumptions, we'll substitute in equation 1 and 2 and let us see what we are going to get. So I have taken input V1 is equal to Vs, Z1 as it is, I1 as it is, and you have Z12, so Z12 as it is, but I2 is equal to minus I2 dash, so that is what it is substituted over here in equation 1, and let us treat this equation as 3, and in the equation 2 we have substituted the value of V2 is equal to 0, Z12 as it is, I1 as it is, but I2 is equal to minus I2 dash. So we framed equation 3, equation 4. Now from equation 4, I can get the value of I1 which is equal to Z22 by Z21 I2 dash. So let us treat this equation as 5, and I am substituting equation 5 in equation 3. Then what I am going to get? So I am going to get Vs is equal to Z11. You have in equation 5 I1 is equal to Z22 by Z21 I2 dash. So just substituting the value of I1 in equation 3 with Z22 divided by Z21 I2 dash minus the rest of the value is as it is, Z22 I2 dash. Now I'm going to take I2 outside and I'm going to divide it by Vs. So Vs by I2 dash is equal to Z11 Z22 minus Z12 Z21 whole divided by Z21. This I'm treating as equation 6. So what I got the condition? I got the reciprocity condition of input source voltage divided by the current which is flowing in the secondary part of the circuit. So this is the reciprocal nature of the circuit, where you can see the input is related to output in terms of voltage and current, and since it is the impedance parameters, that's why you have V by I, that is Vs by I2 dash. So we are framing this equation as 6. Now what if we short circuit the input port and substituting V1 is equal to 0 as well as V2 as source voltage and I2 as the source current? So what happens if we take these assumptions? Likewise, in the previous case, I am taking here again I1 dash which is equivalent to minus I1, or I1 is equal to minus I1 dash. So these values we are going to substitute in equation 1 and 2, and let us see what we are going to get. I am going to get V1 it is 0, and you have I1 is equal to minus I1 dash. So minus Z11 I1 dash plus Z12 I2. I am making this equation as 7, and I am going to substitute the same values of this assumption in equation 2, which will give you the value as Vs is equal to, that is V2 is equal to Vs, which is equal to I1 it is replaced by minus I1 dash Z22 I2. So equation 7 and 8 are framed. And what you are going to do? I'm going to take I2 from equation 7, which is equal to Z11 by Z12 I1 dash. Let me treat this equation as 9. And I'm going to substitute equation 9 in equation 8. Then what I'm going to get? I'm going to get Vs is equal to minus Z21 I1 dash plus Z22. Just we have replaced I2 value over here so that I can get the reciprocal conditions, that is the output voltage divided by the ratio of output voltage by input current. So Vs by I1 dash is equal to minus Z12 Z21 plus Z11 Z22 divided by Z21. This I am treating as equation 10. So what we have done? We have taken input voltage and we have taken output voltage as short for the first condition. Then we have taken output voltage and input voltage as short for the second condition. With this we have framed Vs by I2 dash and Vs by I1 dash. So I'm just equating these two values, Vs by I2 dash is equal to Vs by I1 dash for the reciprocal condition. With this what I'm going to get? I'm going to get Z11 Z22 minus Z12 Z21 by Z21, which will be equivalent to minus Z12 Z21 plus Z11 Z22 divided by Z21. So what we are going to get here? We are going to get Z12 is equal to Z21. Here there is a slight mistake. Please observe here. You have this value. It is supposed to be Z12. It is supposed to be Z12. So that we are going to get Z12 is equal to Z21. So this we are going to treat as first condition under Z parameters. Let me treat this equation as 11, where we got the reciprocity condition for Z parameters is equal to Z12 equal to Z21. Please make a note of this. Now this stands for condition for reciprocity for Z parameters. Now let us see the condition for symmetry for Z parameters. So what we are going to do? We are going to do by open circuiting the output port, that is substituting I2 equal to 0 for this particular two-port network. The output, it is open circuited. It is open circuited indicates that I2 is equal to 0. Then V1 is equal to Vs. We are going to substitute the value of input voltage, and from the standard equation of Z parameters we are going to get Vs is equal to Z11 I1, whereas Z11 is equal to Vs by I1, that is the input voltage by input current. We are treating this equation as 11, and again we are going to take the output voltage and output current by making input port equivalent to open circuit, that is I1 is equal to 0. With this what I am going to get? V2 is equal to Vs and Vs is equal to Z22 I2. This we have obtained with the standard Z parameters. Just we have substituted the values by assuming these conditions. Then I am going to get Z22 is equal to Vs by I2. Now input voltage to input current ratio is made equivalent to output voltage by output current, which will give you the value of Z11 equal to Z22, and this is the condition for symmetry for Z parameters. Please make note of this: reciprocity and symmetry conditions for Z parameters. If at all you have any doubts, please comment in the chat box. Now let us go with the Y parameters. We'll start with the reciprocity condition. So likewise, what we have done for the Z parameters, here also I am taking input source voltage, input current, and I am taking output voltage to be shorted, and I2 is equivalent to minus I2 dash. So this assumptions we are doing. Now V1 is equal to Vs, V2 is equal to 0, I2 is equal to minus I2 dash, and I am taking the Y parameters. These are the standard Y parameters given by equation 1 and 2. Now what we are going to do? We are going to take these assumptions and we are going to substitute in 1 and 2 equation. So to that I am going to get I1 is equal to Y11 Vs. Here we have made output port as short, making V2 equal to 0. That's why in equation 1 this term will go off and we'll be left over with I1 is equal to Y11 Vs. And similarly you have I2 is equal to minus I2 dash. So I2 dash is equal to minus this minus of I2, it will go to the right hand side of this equation 2. It becomes minus Y21 Vs, and this we're treating as equation 4. And the ratio of output current to input voltage, it is obtained to be as minus Y21. This we are treating as equation 5. Please make note of this equation. Then what we are going to do, we are going to check for the condition of reciprocity when input port is shorted. So when input port is shorted, we have to make V1 equal to 0 in equation 1 and 2, and we have to substitute the rest of the parameters, that is V2 equal to Vs, I1 is equal to minus I1 dash. So with this I'm going to frame equation 6 as I1 is equal to Y12 Vs and I1 dash is equal to minus Y12 Vs. So equation 6 and 7 is framed by these assumptions. With this I'm going to get input current to output voltage ratio as minus Y12, and I'm treating this equation as 8. Now from equation 5 we know that I2 dash by Vs is equal to minus Y21, and equation 8 we know that I1 dash by Vs is equal to minus Y12. So we are going to equate these reciprocity conditions, that is equation 8 is equated to equation 5, so that we are going to get Y12 is equal to Y21. Now this is the condition for reciprocity for admittance parameters or Y parameters. Please try to follow carefully. You will understand how we have framed the equations in order to obtain the condition for reciprocity for Y parameters. Now let us go for the condition for symmetry for Y parameters. So these are the standard things which we have already assumed. Now when you are going to substitute the values of V1 is equal to Vs and V2 equal to 0 in the equation 1 and 2, you are going to get I1 is equal to Y11 Vs, such that I1 by Vs is equal to Y11. Now this is the ratio of input current to input voltage, and that is obtained as the admittance parameters Y11. Similarly, where the input port is shorted like this, and the assumptions are made that V1 is equal to 0, V2 is equal to Vs, I'm going to get I2 from equation 2, which is equal to Y22 Vs, so that I2 by Vs is equal to Y22. So just I'm going to equate equation 9 with equation 10, such that input ratio of current to voltage is equal to output ratio of current to voltage, which will give you the value of condition for symmetry for Y parameters as Y11 is equal to Y22. Just make note of this derivations. And finally, we are going to frame the tabular column for the condition of reciprocity and symmetry. So once we are done with Z parameters and Y parameters, let us switch on to ABCD parameters. For ABCD parameters, you need to remember the standard equations of V1, I1, that is input voltage, input current in terms of output voltage and output current. So here you can see the standard equation is given by AB2 minus BI2, CV2 minus DI2, that is the output parameters in terms of input parameters of voltage and current. Now when the output port is shorted, the same assumptions what we have done, we have made equal of source voltage as input and V2 as 0, that is shorted, and I2 is equal to minus I2 dash, and we are going to substitute these values in equation 1 and 2. Let us see what we are going to get. We are going to get Vs by I2 dash is equal to B, that is the first reciprocity condition. We are making this equation as 3, and then we are going to take the input port to be as shorted, making V1 equal to 0, and we are energizing V2 is equal to Vs, that is supply voltage with the driving current as I2, and assuming I1 is equal to minus I1 dash according to the direction of these two currents. So what we have done, we have done these assumptions, and we are making the input port as shorted. So we are going to substitute these values in standard equations of ABCD parameters. So we are going to frame equation 4, that is V1 which is equivalent to 0 as A Vs minus Bi2, and the second equation of ABCD parameters as minus I1 dash is equal to CVs minus Di2. So equation 4 and 5 are framed. Once these two are framed, I'm going to get A by B, Vs is equal to I2 from equation 4, that is equation 6. And I'm substituting equation 6 in equation 5 to get minus I1 dash is equal to CVS, this is the value, same value, minus D. You have I2 from equation 6, it is substituted as A by B Vs, so that I'm going to get the value of I1 dash in terms of Vs, such that Vs by I1 dash is equal to B by AD minus BC. So this we are treating as equation 8, that is a reciprocity condition. And by equating equation 8 with equation 3, I'm going to get B is equal to B by AD minus BC, that is Vs by I2 dash is equal to Vs by I1 dash. So that is what we have done by equating equation 8 with equation 3. And with these two terms on left hand side and right hand side, you are going to cancel out the B term, so that AD minus BC will be equivalent to 1, and this equation 9 is the condition for reciprocity for ABCD parameters. Please follow step by step what we have done here. Later on we are going to tabulate all this value in a tabular column in order to understand how we have obtained the condition for reciprocity as well as symmetry. Now let us go for the condition for symmetry for ABCD parameters. For that we need to open circuit the output port as well as the input port step by step. So when the output port is open circuited and that value is substituted in equation 1 and 2, we are going to get Vs is equal to AV2 and I1 is equal to CV2. So we get the input voltage to input current as A by C, that we are treating as equation 12. Similarly, when the input port is open circuited, that is made I1 equivalent to 0, and substituting the equation 1 and 2, you are going to get Vs by I2 is equal to D by C. So you just equate equation 12 with equation 13, that is the input voltage to input current is equal to the ratio of output voltage to output current, will give you the value of condition for symmetry as A equal to D. I hope you have habituated how we have framed these equations step by step. We are following the same procedure for all the two-port parameters. Now let us go with the last parameters, that is the hybrid parameters. Let us go with the condition for reciprocity. For that, the standard equations of H parameters are taken and the assumptions are made, like V1 is equal to Vs, V2 is equal to 0, I2 is equal to minus I2 dash. And I'm going to substitute these assumptions in equation 1 and 2 when output port is shorted. So I'm going to get Vs is equal to H11 I1 and minus I2 dash is equal to H21 I1. So that Vs by I2 dash is equal to minus H11 by H21. Let us treat this equation as 5. Then what? Then we are going to take input port to be as shorted, that is making V1 equal to 0 and energizing V2 is equal to Vs, driving the current I2 and making I1 which is dependent upon I2 which is equivalent to minus I1 dash according to the direction of the currents over here. So with this I'm going to get 0 is equal to minus H11 I1 dash plus H12 Vs. This we have obtained from equation 1. And similarly I'm going to get Vs by I2 dash is equal to H11 by H12. Let us frame this equation as 6. So that we can equate equation 5 with 6 and we can get the condition for reciprocity for hybrid parameters, which is equivalent to H12 is equal to minus H21. And finally, the condition for symmetry for H parameters when output port is open circuited, I'm going to get V1 is equal to Z11 I1 plus Z12 I2. I'm taking the help of Z parameters, so that Z11 is equal to V1 by I1 and I2 equal to 0. And the H parameters are given by V1 is equal to H11 I1 plus H12 V2. Just I'm taking this V1 over this particular numerator, so that I'm going to get Z11 is equal to H11 plus H12 V2 by I1. I'm treating this equation as 7. Then what I'm going to do? I'm going to take the second condition of H parameters, that is I2 is equal to H21 I1 plus H22 V2. With this, I'm substituting the value of I2 equivalent to 0 and I'm going to get V2 by I1 is equal to minus H21 by H22. Now Z11 will be equivalent to H11, that is this value from equation 7, minus H12 H21 by H22, which will give you the value of Z11 to be equivalent to H11 H22 minus H12 H21 whole divided by H22. So that will be the value of Z11 will be equivalent to delta H, because this it is the determinant value, divided by H22. This we are treating as equation 9. Now when the input port is open circuited, from the standard equations of Z parameters and H parameters, I am going to get Z22 is equal to V2 by I2 at I1 is equal to 0, and H22 will be equivalent to I2 by V2 at I1 is equal to 0, so that Z22 will be equivalent to 1 by H22. So this we have done directly from analysis of Z parameters and H parameters by concentrating on the equations respectively. So we framed equation 10. Now for a symmetrical network, Z11 should be equivalent to Z22, right? So we have taken the value of Z11 and it is obtained to be delta H by H22, and Z22 is equal to 1 by H22. Hence, delta H is equal to 1. Now this is the symmetry condition for H parameters. This we are treating as equation 12. So we have seen, we have followed the step-by-step procedure in order to obtain the reciprocity and symmetry conditions for two-port networks in terms of Z, Y, ABCD and H parameters. Let us tabulate all these things in a proper way so that we can remember the things in much more better way. Just you remember these reciprocity and symmetry conditions for future analysis. The important part, that is the derivation part, we have done in this particular class. So what we have seen parameters, that is all the two-port network parameters, and we have framed the condition for reciprocity as well as the condition for symmetry. So we have four parameters. So we are taking serial number as 1, 2, 3, 4, and the parameters which are taken here are Z, Y, ABCD and H. T indicates the transmission line parameters, that is ABCD parameters. So what we got, the condition for reciprocity for Z parameters, we got Z12 is equal to Z21, and the condition for symmetry is Z11 is equal to Z22. I hope this is clear. Then condition for reciprocity for Y parameters, it is Y12 is equal to Y21, whereas Y11 is equal to Y22. This is the condition for symmetry. For admittance parameters, for transmission line parameters, we got the condition for reciprocity, which is equivalent to AD minus BC is equal to 1, whereas A is equal to D. This is the condition for symmetry. And finally, we got H12 is equal to minus H21 as a condition for reciprocity for H parameters, whereas delta H is equal to 1. This is the condition for symmetry for H parameters. So in today's class, we have learned all the reciprocity and symmetry conditions of standard two-port networks, that is Z parameters, Y parameters, ABCD parameters and H parameters. I hope you like this video. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications.